For section 2.5, we are going to be dealing with measures of the center of data. And so we want to, again, remind ourselves that when we talk about parameters, we are talking about descriptive measures of populations. When we talk about statistics, these are descriptive measures of samples. So it might be the same type of information, but one is talking about all the items in your population, and the other one is only talking about a subset of your population, which remember is called a sample. Parameters are often written using Greek letters. Mu is the one that is used for a population mean, and that's that little thing that kind of looks like a cursive U, but it's a Greek letter mu. Statistics are often expressed using Roman letters or some variation of them, and for the sample mean, we use what is called X bar. That's a little X with a line, a bar over the top of it. The arithmetic mean is where we're going to start talking about measures of center, and many times in the past you would have heard this called the average. This is obtained by taking the sum of all the values in the data set, so you add them all up, and then divide by the total number of observations. So if you are adding up 12 numbers, you add up all those 12 numbers, and then you would divide by 12. Just like when we found our median, in the last problem, the last lesson, we had to add those two values together, and we added two values, so we divided by 2. So in particular, here are our formulas. For the population arithmetic mean, this is computed using all the observations in the entire population. Remember that the population mean, we use that symbol mu, it is a parameter. And in equation form, this is what it looks like. So mu equals, and this stuff right here just means we're going to add up all of those observations. X sub 1 plus X sub 2 plus X sub 3 plus X sub 4, all the way up to where we finally get to the nth observation. And remember that n is the total number of values in our population. So we would have to add them all up, and then we divide by n. Now you may remember seeing this on the calculator when we were looking at some of the things earlier, but this symbol right here, this is a symbol, this is a capital Greek letter sigma, and what that means in math many times is that we are going to take the sum of a group, and so that's what this is saying. We're going to take the sum of all of these x values, and you can see that right here. So this isn't actually telling us anything different, it's just giving us an abbreviated way of writing it. And sometimes when you'll see formulas, you will see that sigma sign in there telling you that you should add up all the values. And then remember again that the n is the size of the entire population, so that's why we're dividing by uppercase N. The sample arithmetic mean is computed using all the observations from the sample. So remember, the sample is a subset, it's a smaller group from the population. The sample mean, X bar, is a statistic because it's just from a sample, and in equation form you'll notice it looks almost identical to the other one. X bar equals, and here we're going to add up all those values from the sample. We only have lowercase n number of values in our sample, so that's why we divide by lowercase n. And then again we have that sigma version of the addition process telling us to take the sum of all the x's and divide by lowercase n, and lowercase n is the represents the size of the population. There's a typo that I didn't notice. It represents the size of the sample. That must have been a copy and paste from the previous slide, but it represents the size of the sample, the lowercase n. Example 215, the following data represent the travel times in minutes to work for all 7 employees of a startup web development company. Compute the population mean of this data and round your answer to the nearest tenth. So to find the population mean, we add up each of these values. And I'll grab my calculator and do that in just a second. So that's our first step, find the sum of all those values. And notice this is a population because it's all 7 employees. And then it even says population mean. So we're going to add these up, 23 plus 36 plus 23 plus 18 plus 5 plus 26 plus 43. So we get a total, the sum is, so this is going to be mu equals 174 divided by, and this was 7 people, so divided by 7. 174 divided by 7, and we're going to get to the nearest tenth, 24.9. And remember, that is minutes, because that was the units we were given. So that is mu for this data set. And I'm going to keep that information up there even as we go on to our next examples, because we want to use that to compare to something else in a minute. Now we're going to determine the median. So in order to determine the median, remember that we want to put these in order. So I'm just going to rearrange them. 5 is our lowest value now, then 18, then 23, 23 again, then 26, 36, and 43. And since we had 7 of them and we're finding the median, there is a middle number. It's this 23 right here. And so our median of this group is going to be 23. That's the middle number. Okay, so again, just repeatedly being able to find that median. We're going to go ahead and go on to the next example and keep this information here. For the next example, it says, suppose that this company hires a new employee and the travel time for the new employee is 70 minutes. Determine the median of the new data set. So notice we've added that 70 onto the far end, and we are going to find the median of the new data set. I should have maybe left them in order already, but here's 5, 18, 23, 23, 26, 36, 43, and 70. So this time we have 8 values, so we have to count 4 below the median and 4 above the median. We will have to take the average of those two. So 23 plus 26 divided by 2. I'm going to grab a calculator just to make sure I don't mess that up. It's 24.5. So our new median, we'll call it median 2, is 24.5. We'll call this median 1. The other thing I actually want to do is I'm going to go ahead and calculate the mean of this data set as well with the new 70 put in there. So we're going to add all those up. We already know that the sum before was 174. So our new sum is going to be that 174 plus 70 more. It's going to be 244. And we know that we used to have 7 numbers and now we have 8. So we're going to add those up. We'll get 244 and then we're going to divide by 8 this time. And that is 30.5. And the reason I wanted to do that is to compare the two mean values. Notice the mean jumped pretty drastically. It jumped about 5.5, going from when we add that 70 in there, it jumps 5.5. But notice the median only jumps a little bit. It does increase, but it only increases to 24.5. So we're going to have a term for that in our next slide, but I want to kind of point out that those don't change the same amount. One of them changes quite a bit. The other one changes just a little bit. A numerical summary of data is said to be resistant if extreme values, very large values or very small values, relative to the rest of the data, do not affect its value substantially. So in that case, we saw an example. The median is typically resistant, and on the other hand, the mean is not resistant. The mean tends to swing pretty drastically in one direction or the other when you have those possible outliers, the ones that are really large or really small compared to the rest of the data. Our third measure of center that we have talked about, and you probably have done these in the past, we talk about mean, median, and mode. Those are the 3 measures of center. The mode of a variable is the most frequent observation of that variable that occurs in the data set. So a set of data can have no mode, it can have 1 mode, or it can actually have more than 1 mode. If there are no observations that occur more than once, we say the data has no mode. So that's what will happen. If there are no observations that occur more than once, you have no mode. On the other hand, anytime one will appear more than once, then you have that possibility of having a mode. For example, 220, what is the mode for the weights in pounds of the 10 students in the nutrition class? So the easiest way to probably do this is put these in order. That way you can see them written right next to each other. So we've got a 95. Next we have, it looks like 117 and another 117. Then we have 130, 133, 145, 154. Then we jump to 193 and 210 and finally 268. So once you had it lined up, if you wanted to, you could identify the median. But what we're looking for is the mode. And if you look, only one of these values occurs more than once. So our mode in this problem is 117. For example, 2.21, and depending on which set of notes you're using, I did change this example a little bit. I switched that last option to yellow instead of, I don't remember what it was, maybe green. So we're going to find the mode of the data set of colors. So notice this time it doesn't make sense to try and put them in order because there is no order with colors. It's qualitative. And going back to our types of data, this is a nominal set of data. Because you can just name it, you can't really order it. But be sure to interpret your answer in the context of the problem. So let's just write down the possibilities. We have some that are blue, we have some that are green, we have some that are red, and yellow. So blue, let's count them up. We've got 1, 2, 3, 4, 5 that are blue. I maybe should have underlined them in blue. That would have made sense. 1, 2, 3, 4, and 5. So 5 of these values are blue. Then we can go to green. There is 1, 2, 3 greens. Then we can go to red, and we have 1, 2, 3, 4, 5 reds. So 5 reds. And then finally, yellow. We just had that one yellow at the end. So those are our totals. And so what that means is, notice the blue occurs 5 times, the red occurs 5 times. These are both modes. We have 2 modes in this case. The modes would be blue and red. So in the context of the problem, what does that mean? It means blue and red occur more than any of the other data values in our set, any of the other colors. Now we want to recall example 2.4, and we want to find the sample mean. But notice this is a frequency distribution. So one option that we would have is, we know that 85 occurs 4 times. We could write 85, 85, 85, 85, and then we could write 98 and 98. We could write 100. We could write 110 4 times. And we could list these all out and we could add them up. But an easier way to do this is to realize that if you have 4 85s, all you have to do is multiply 85 times 4, and repeated addition is multiplication. So 85 times 4 is 340, and that would be the sum of all of those. So we don't have to write them all out, we can just multiply. For the next one, 98 times 2. And 98 times 2 is 196. Actually, let me put all these time signs in here because that's what we're going to do on each of these. Then we go to the next one, and that one is clearly 100 because it's just times 2. The next one is 440. The next group is 345. And then the last group, 138 times 2, is 276. Now we're still wanting to add all of these up, so we're just going to add up all those totals for each row. So 340 plus 196 plus 100 plus 440 plus 345 plus 276, and that gives us 1,697. Now we are finding the sample mean, so this is going to be x bar, and it's going to be 1,697 divided by, and then we have to figure out how many total people we were adding up. Now, if you're looking over here, you can see it's not just 6 values from our rows, it's 4 values here, 2 more here, 1 more there, and so we've got to add up all of these to find our total. So 4 plus 2 plus 1 plus 4 plus 3 plus 2 is 16. That is our total number of values, so that is what we are going to divide by here. 1,697 divided by 16, and we get 106.1 if we round that off. Remember, we'll round to the nearest tenth because our data was given to the nearest integer, and we always do 1 additional decimal place. So 106.1 is our mean for that data set. Steps for calculating the sample mean for grouped data. So this is not exactly what we just did. This would be where we don't know the individual values, but we know the group values. So the way we would do that is we multiply the frequency of each, First, we'll calculate the midpoint of each group. Then we will multiply the frequency of the group by the midpoint of the group, just like we did with those individual values on our last example. Then you're going to add up all those products, just like we did on our last example, and divide by the sample size, which is the sum of the frequencies. So very similar to what we just did. The only difference is, since we don't know the individual values for each row, we're going to have to use the midpoints of the group to use as the values to estimate that. So recall the example from 118 where we were given the sample of group data for the cost of textbooks. Find our sample mean and then the median for the grouped frequency distribution table. And we're going to do, like I said, it's basically the same thing we just did. We're going to have to multiply the midpoint, which is already calculated for us, so we don't even have to find that for step 1. And we're going to multiply that by the frequencies. So let me grab my calculator so I keep that handy. The first one here is going to be 640. The second one is going to be 200. The third one, I think, is 960. Let me double check that. Yep. The fourth one, 280 times 6, is going to be 1680. Then we have 3,200. Then we're going to have 360 times 6 is 2,160. And that one is going to be 800. And 440 times 3 is 1320. So we're finding x bar, which means we need to take the sum of all of these. So we're going to add all those up. Add all these up. And 640 plus 200 plus 960 plus 1680 plus 3200 plus 2160 plus 800 plus 1320. And that adds up to be 10,960. Then we want to figure out how many values we had. So we've got to add up all these frequencies, because each one of those represents a response or a person spending that much money. So 4 plus 1 plus 4 plus 6 plus 10 plus 6 plus 2 plus 3. And that gives us 36. So we will divide by 36. 10,960 divided by 36 gives us, and again, we'll round to the nearest tenth. This is $304.4, and that is our X bar for this particular example. So 304.4. So very similar to the last one we did, where we were given a frequency distribution. When we're given the grouped frequency distribution, the process is pretty similar. The only addition is we've got to find these midpoints first unless they are given to us. That is the end of section 2.5. And again, you've got those 6 problems to work on. If you get stuck, please let me know. Send me an email. Send me a message on the MyOpenMath program. Either one of those would be fine. And but take a shot at those 6 and see how they go.